database. In the HANA cockpit, we started it. Yesterday we stopped for some recovery, I guess. So then we have not started. Now I am starting the database. It is starting mode now. So while it is starting, see here we have some allocation limits, memory allocation limits, some restricted features. So many features are available, backup schedules, so tenant replications, configure the replications, licenses. Many features are there in the HANA cockpit. That is what we are discussing in the last few days onwards. We are discussing, right? So remaining things you can practice it, just experience with the all these tabs and everything, or you can remember what are the new options are available in the databases and everything, right? So it is started. You can see. So running with the issues. So it is started. What are the issues here? Running with the issues means. So let's see here whether now it will connect or not. So running with the issues. Okay. Automatic backup is disabled. DB backup does not exist without backup. Okay. Backup is does not exist. It is saying that. So we can take the backup also. So that's not a problem. Thing we scheduled. Now it's connected. You can see here. Now it is connected. So now it is connected. So now the topic is which we are going to discuss about the HANA memory management, right? Memory management. So HANA memory management, SAP HANA memory. So memory management. So why we have memory management dedicatedly we are discussing for the HANA. So as we speak, as we discussed it last time, HANA is purely on the memory mentality. Means it will use the main memory. It will use the RAM memory. Why? Because data will store only on the RAM memory store. So whatever the RAM is there, whatever the free memory is there, it will use the free memory. It will use it. So, but we need to restrict it, right? Like how the memory allocation will happen for the HANA database. First of all, how the memory will allocation will happen. So let's start discussing about the. So we have in the HANA Studio, we can see here HANA used memory and HANA resident memory. What is that name? What is that mean? HANA used memory, HANA resident memory. So how can we restrict this one for usage, right? This is the one. So suppose here, suppose if you take, you have built the new operating system, new Linux operating system you have built here, right? This is your operating system. Sir, operating system is this like this. I'm also not sure. Just assume, okay? And this is the your RAM, right? This is a RAM slot. You put it here. This is the RAM here, right? This is your RAM. So let me write it here to avoid the confusion. RAM means physical memory, right? Physical memory. Physical memory. So on top of your operating system, on top of your operating system, so what you are going to install? This is your RAM. When you install the OS, it will occupy the some amount of OS process, right? Some amount of in your total RAM, it will use the some OS process which will use it. OS code, OS programs, it will use the some amount of memory. That's why entire your RAM, I will put like OS and other programs will use the OS and other programs. OS and other programs will use this your RAM, right? Immediately when you install the operating system, either Windows or Linux, so some internal process, internal code will use the some of the memory, right? So that is what. So in the entire your memory, it is using the this much of memory. This operating system is installed. Then on top of this operating system, then you have installed the. We'll go for the green. So we'll install the HANA, right? HANA. This is your HANA. You installed it, right? HANA you installed it, and HANA you installed, and you have given the some limitation for the HANA, right? This is the HANA. This green color box is like HANA, right? HANA. Let me write it here. HANA. HANA, SAP HANA, you installed it. Why? Because HANA is the main memory concept. So that is the reason main thing you have installed in the HANA. This is the, you have not given full memory to HANA database. it should be some free memory required here. Free physical memory is required for HANA database. Sorry, not only OS. So if your OS, you should not allocate the free memory, you should not give the free memory to OS. The OS will hang, the OS is hung, entire your HANA database will be go hung status, right? So enter this one, you given the some physical memory, some free memory to the your operating system, right? You have operating system. So this entire HANA box, when you install the HANA database, immediately it will go and so occupy the 900 GB, right? It will go and occupy the 900 GB, right? It won't occupy the 900 GB here, entire in HANA database, right? In this case, what exactly happens in the HANA database? In this case, what exactly happens in the HANA database, right? So here, when you install this box, only this box I am talking now. Why? Because this is you clear entire. This is the OS and this is the OS memory. The remaining memory called the HANA memory. HANA allocated memory. HANA allocated memory, right? HANA allocated memory, right? So when you install the HANA database, it won't immediately use it. So it will use the some amount of memory. It will use it when you install the HANA database. So it may be 2, 4 GB, 7 GB. It will use it. Why? Because in internal HANA internal we have so DBMS related items, right? Database related things, some column store tables and row store tables, column store tables, row store tables, some system internal tables. So all are available. Some internal tables all are available here. System tables and everything all are available here, right? All are available here, right? So this suppose like I may put like here system tables, some row store tables, HANA level. So column tables, already existing column tables, existing one, right? Then database related, DBMS related computations and everything will be available here. Then this is the free database memory, database level free memory. It's called the memory pool. This is the memory pool. Okay, this is the memory pool here. So up to this box, this yellow box is not yellow, green box. This green box is the HANA memory. In HANA, when you install the HANA, it won't occupy the entire your memory, right? It won't occupy the entire memory. It will use the some amount of memory, right? When you install the new HANA database, it won't occupy the 100% of your memory. It will use the 7 GB or 8 GB. So 7 GB, 8 GB. In that 7 GB, 8 GB, what are they called means in the 7 GB, 8 GB? So here, so maybe database related tables, internal tables. So maybe column store tables, row store table, all will be available in the here. So enter this memory, thick memory is called the HANA used memory. HANA used memory. Enter this thick memory is called the HANA used memory. This memory is called the HANA free memory. How much free is there here? You can see. So out of 32 GB, you allocated total resident memory. Total resident memory means what is it mean by resident memory here? So resident memory means free plus HANA used. Free plus HANA used is called the resident memory. So free, suppose like, where is that screen? So resident memory means, resident memory is the 36 GB. Suppose out of 33-G, total 36 GB for the OS we have, right? 36 GB. So 36 GB you allocated for the 36 GB is the memory which is using by the your OS plus HANA, OS plus HANA memory, HANA free plus HANA used memory. All this memory is called the resident memory. Why? Because in your RAM, OS is residing and HANA is residing, right? OS and HANA is residing. That memory is called the resident memory. Resident memory. That's why resident memory is the very big size memory. So in that, the special memory, HANA used memory is the 8 GB, but how much you allocated for the HANA memory? So that is called the 32 GB. In the 32 GB, 8 GB is allocated for the HANA. So remaining how much is free? Remaining 26 GB or how much? 32 minus. So 8 GB, if you remove it, how much will come? Remaining this much memory is the free for HANA. But OS, this much of memory is free here OS. So if this memory is consuming means this memory also will start using it here. But it will not use the entire memory. Why? Because HANA we given the 32 GB and OS give the 36 GB, means 4 GB is left. Then when it starts using the HANA 32 GB, then HANA will be crashed. Why? Because you given the thresholds like 32 GB only. It will be crashed. Crashed means index server will be restarted due to lack of memory. So this is the memory area. This is the HANA free memory. This is the OS free memory, right? So HANA, if you don't set the HANA, then what will happen? It will start using the all the memory. As of now, it is started using the used memory is the this one 7 GB. Then it will start using the free memory also. Free memory also it will start using. Even if the free memory also over, then it will start using the operating system memory, OS free memory. Then OS free memory it will use it. Then OS free memory also over. Then OS will go to hung status. OS will hung status. Then even SAP, HANA, no one cannot log in. Again, we need to reboot the OS to free up the memory, right? So that is what the memory will allocation will happen. So HANA used memory means some system tables, row store tables, column store tables, database. Currently database, whatever the data is stored, that data, that all are called the HANA used memory. Free memory means entire your HANA, suppose, so how much entire free memory means? Entire your HANA 32 GB, you have 7 GB or 8 GB already allocated, right? 32 minus 8 GB, then how much it will come? Free. That much of free is called the free memory pool here. It will use it this free memory pool. But if this is also over, it will start using the operating system memory. That's why we will set the allocation limit here, global allocation limit. We will set the one boundary here. That is called the memory allocation limit. We will set it here. Memory allocation limit. We will set it here. Global allocation limit. We will set here, right? We will check. We have checked this one. Allocation limit. Global allocation limit. So if you set this one, global allocation limits, what will happen? If we set this one, whatever you do the settings here, only it will start using the that much of memory only. It won't occupy the operating system memory. If you don't set the boundaries, what will happen? It will start using the entire your memory. It will start using the entire your memory. It will start using it, right? Entire it start using it. So now you know what is mean by resident memory means OS plus HANA. OS plus HANA. This all are OS plus HANA. This block is called the resident memory. This is called the resident memory. Resident memory. HANA memory means HANA used memory means HANA only using, not the OS memory. HANA only using this one. Entire HANA memory means HANA used plus free memory equal to called the entire HANA memory. Resident memory means so everything like free, HANA used and OS, all this memory is called the resident memory. Physical memory means free physical memory. Entire your RAM slot is called the free physical memory. So that is called the HANA memory management for the each and every process. Right? Any questions here from anyone? I hope it's a very confusing part, but you should remember all these things. HANA used memory, resident memory, all these things you should remember. So got it? Any questions, confusion here?
No, sir.
Is it clear? Or do you want me to explain one more time? Okay.
Clear,
Let
sir.
me, yeah, let me explain one more way. We'll take your daily usage, daily routine activity, right? Daily activities. So here, if you have any, all are Telugu people or anyone, I think Telugu. Okay, Wazina, you are not Telugu, right?
Yeah, no.
Okay, sorry. Yeah, sorry for asking. Yeah, just want to explain the one simple scenario in Telugu. Not a problem. Okay, let me explain. This is the one tub here. Okay, this is one tub here. Tub, right? Maybe bucket, whatever you can call it as tub. So in this bucket, when you, so in the bucket you pour this some water here, right? When you purchase the one bucket, maybe it's not a good example, but okay, let me try to explain this way. Okay, this is your bucket, right? This is your bucket. In this bucket, so in this bucket, so suppose like 100 liters bucket, 100 liters bucket. In this 100 liters bucket, so you poured this some water, some Hana water you poured here, right? So you filled it here, but you have not filled everything here. Maybe it's not a good example. Okay, we'll take another example. Sorry.
పర్లేదు సార్ చెప్పండి, ఏం కదా.
సో అంటే ఇక్కడ మనకి కొంచెం వేరే డిఫరెంట్గా వస్తుంది అనమాట, ఇంకో విధంగా వస్తుంది అది. అంటే ఫస్ట్ మనకి ఇక్కడ ఓఎస్ కాబట్టి ఇన్స్టాలేషన్ కొంచెం మెమొరీ ఆక్యుపై చేసేయాలి కదా. సో ఆ మెమొరీ ఏమి ఇవ్వాలి, ఇక్కడ మనం వాటర్ ఇస్తాము, అనాకి వాటర్ ఇస్తే రిమైనింగ్ ఇదేది ఇవ్వాలా. సో అక్కడ కన్ఫ్యూజ్ అవుతుంది అనమాట. సో మీ వరకు నేను సపరేట్గా చెప్తాను. సో హియర్ entire bucket, this is the 100 GB RAM, right? In the 100 GB RAM, when you install the OS, it is occupied the 2 GB, right? 2 GB it is occupied. Suppose like 2 GB for HANA, for OS. This OS programs and everything, it is using the OS and some other programs, OS related code and stacks, 2 GB. So on top of this 2 GB, so 98 GB is left now till, right? Out of 100 GB, you given the minus 2 GB for the OS it is using, right? So remaining, right? So remaining, you install the HANA database here. You install the HANA database. So when you install the HANA database, so you allocated the some amount of memory to HANA. Maybe out of 100 GB, so 2 GB this one, 3 GB free, 3 GB OS you are giving free, 3 GB free physical memory, right? Physical memory, right? You are giving. So total 5 GB allocated, 5 GB allocated for the OS only. 2 plus 3 free memory, free space, free memory allocated, right? Now remaining 95 GB is for the HANA. Remaining 95 GB is HANA. In that 95 GB for HANA, all right? In that 95 GB, so immediately when you install the HANA, immediately it won't go for the, immediately it won't occupy the 95 GB, right? Maybe it will occupy the 45 GB, right? Maybe 45 GB we will allocate for the HANA. This is called the HANA used memory. Currently HANA using memory, that is called the HANA used memory. Maybe 45 GB for HANA. This is called the HANA used memory. HANA used memory 45 GB. In that 45 GB used, next 55 GB free memory is there. Free memory, 55 GB free memory, 55 GB free is there. Free memory, 55 GB free memory is there here. So this is the 45 GB. 100, right?
Out of
Oh, sorry.
40.
Yeah. Not the 55 GB. How much? So 5 is there. 50.
50 GB, sir.
Yeah, 50 GB. Yeah. Okay, 50 GB, right? 50 GB. 53. So 50 GB. Okay, 50. So OS is using the 5 GB. Then this is the 45 GB. Then this is the 3 is the 50 GB. 50 used memory. This is the using currently. Used memory means currently code, stacks, all these things, HANA code, stacks, tables, row storable data, some all blah, all is using this 45 GB currently. So whenever it's required the memory, whenever new data comes, it will start using your free memory pool. This is called the pool. We will call it as it will pull the data from free memory. It will start using the free memory. Whenever some request, it will start using consuming the so full memory. Then in that case, if you set the thresholds, it will be cancelled. If you don't set the threshold weapon, so what happens? One of the statements will be consuming the more memory, then more operating system memory, then it will use the free physical memory also. Then in that case, what happens? Entire your HANA OS will be crashed. To avoid that one OS crash, just we will set the limit, the allocation limits, memory limits, we will set it here so that it won't use the remaining your free physical memory, it won't use it. It will use only up to this free memory, will use it. The statements which are using more memory, so then it will be cancelled. Once it is cancelled, then the memory will be freed up. So once the statement is executed, the memory will be free up again. It will be free up. Okay. So if the data is storing, it will start using this much, this much, this much, this much. It will consuming the free memory also, right? So that is the one. So then this is the how the memory how the it's reached to the entire limit, how the OS crash, and how to limit the memory and everything. This is the one. So this is the HANA used memory. Used memory plus this remaining 50 GB. This entire memory is called the 95 GB is called the HANA memory. HANA memory, HANA resident, entire this memory, HANA memory. So this OS plus HANA used memory plus HANA free memory plus this all are called the resident memory. Resident memory. We will call it as the resident memory. So entire this HANA free plus used memory is called the HANA memory. In entire HANA memory, how much it is using? 94 GB or 5 GB or 45 GB, right? Free 50 GB. So it will use it. So this is a small calculation. How can we limit? Means we have to separate it. If you have the two HANA boxes, if you have the two tenants, in that case, you need to separate it. Suppose in the two HANA boxes, suppose 15 GB for this tenant, 15 GB for that tenant, you have to segregate it. Like that, you need to separate it. So you have the 1 terabyte RAM. How can we separate it? Suppose they may ask you questions like, if it is the HANA using the, suppose this is the HANA. So you want to install the two tenants, then you have to do the separation partition, right? You have the one chocolate. How can we do? If you have the one chocolate, means 1 terabyte RAM, you have the two kits, two HANA servers, then how can we separate it? Right? You can equally give the, you can equally separate, equal amount, you can separate to the your kits, right? Same way here also equally we have to put it in. Then how you are doing means in the HANA, in the configuration, in the set allocation limits, you have to set it here. Allocation limit, the memory global allocation limit, you have to set it here. Maybe 20 GB, then you can give the 20 GB for, so one kid, 20 GB for one kid, then remaining, not tenanted data, system maybe you need to do. So one remaining GB for the remaining HANA server, you can kid it. So if you define this one, HANA will use whatever the parameters we have here. The allocation limits. So whatever the limits we have here, maybe 25 GB. Whatever the limits you set here, see here, oh, 244 GB. What is this, man? We don't have that much of that. I think wrongly selected the extra 0. Yes, 24 GB. So remaining memory you can allocate for the other tenant. So this HANA will use this one come to the here, then it will be blocked here. Then once it is reached to the 24.41 GB, HANA will be restarted. Why? Because HANA is purely based upon the memory mentality. It will use the memory, right? So that is the reason. So remaining GB you can allocate to the remaining memory, remaining systems you can allocate. This way, in one host, if you have the two databases, this way you need to segregate your RAM memory to the HANA systems, right? This way you need to segregate the systems to the HANA. So I think, yes, I think someone shared the screenshot. You can see here. Yeah, memory allocations, how the memory allocations is happening. Someone is shared the screen. So used memory columns, free memory. So you can see memory consumption for the index server was critical. So yeah, you can see here. Last time we see in the EW report, right? Same way here. Okay, this is about the HANA memory usage. Disk usage, we know df-hash, we can see this is the data volume disk usage. This is the /HANA log. This is the /HANA trace. This is the disk usage, we can see it here, right? So volumes, usage, everything we can see it here. Okay, so this is the disk usage. Okay, this is about the HANA memory management. So yeah, any questions before we go for the HANA HA replications now? The next topic which we are going to discuss about the HANA HA, HANA high availability. So what is mean by high availability? I will give the some theoretical introduction today. So that you will be tomorrow we can configure the replication modes. So yeah, then we have the system copy procedure. That is the last step. Then SAP memory management is there. Tomorrow we'll complete those things. Okay. So
Sir,
you are
DB refresh is also.
system, yeah, DB refresh means system copy will come. Yeah, DB refresh. That is the topic we will pending.
Okay, sir. Sir, that one's a provisioning something.
Now provisioning also pending. That I have to fix that drivers issue. So I'm not getting the time, but I will fix it. So don't worry. I will discuss those things also. Not a problem.
Okay.
Okay. So we'll slowly discuss those things. Thanks for bringing the topic. So we have to discuss those provisioning also. So tomorrow we'll complete 2 topics, maybe HA and maybe provisioning. Today, if I get the time, so I will work on the drivers issue as well. So that's not a problem. It's a small thing. That is also very small thing only. We can complete. So if everything is okay, then I can start discussing about the HANA high availability. Some theoretical topics I can discuss, right? So what is mean by HANA HA high availability? So HANA HA. So HANA now as of now we have installed the HANA database in the single host, right? Single host we have installed. So, but suppose your HANA system is the mission critical, very important DB database. In that case, we can also install the HANA in the multi-node concept, multi-cluster concept we can do for, which means this is your HANA database. You can install in one host, you have installed the one HANA database. In another host, you have installed the one more HANA database, you have installed it. One HANA database, one more host, you have installed the one more database. This is in the one side, this is in the different side. Okay, this is different area. So your SAP application, this is your SAP application, right? All users, they will connect to the HANA database, sorry, SAP. Then this HANA will point to the one of the virtual IP here, right? Virtual IP to connect to the database. So to connect to the database, it will point to the one virtual IP here. This is the virtual IP here. It will point to the virtual IP. So that this virtual IP will point to this server, this primary, and this secondary server, it will point it. This primary and this secondary server, it will point it. Primary, it will point it. Secondary, it will point it, right? The relaying IP forwarding rule. So it will point to the 2 IPs here, right? So this is the HANA. So this is the HANA. So this is the HANA. So for this is the HANA 1. This is the HANA 2. So here this is our SAP system. So users are logging into the SAP system. They are working on the system. SAP will will store the data into the database level, right? The primary database. At a time it will not store the data into the secondary database as well. Only primary it will store the data, right? So then it will store the data here. Then here, what we will do here tables are there, data is there, everything. But if something goes wrong here in the primary, then immediately it will fail over to the secondary, right? It should go to the secondary. Then immediately the secondary should be up. Then immediately the secondary should be up. Then immediately the secondary should be up. Then here we need to, but secondary should be up, the database, the IP which will point to the secondary. But there is no data. Why? Because the users related SAP data will storing into the primary only, right? In that case, if you configure the replication, the data replication from database related replication from primary to secondary, if you configure the replication here, whatever the data comes to the here, same data will be replicated to the secondary data also. The user done one transaction, same transaction will be available in the secondary database also. The user done some payment, same payment is available in the secondary database also. So why sir we are replicating the data into the 2 databases? Suppose in worst case scenario, your data 1 is stopped due to some memory error. Immediately SAP it won't down. SAP will reconnect. I mean, because immediately the services will switch over to the secondary. Your transactions, everything in the secondary. Then HANA will fail over to the secondary. Then users start using this SAP. Then, but database only change it to the HANA 2. Then meanwhile, there is no business impact. Then you can start working on the HANA 1, what is caused and why HANA failover happens, which or happens, you can work it out. But data perspective, we have the replication. Replication will go to the primary to secondary, which it will go to the secondary, primary to secondary, it will go to here. Right? So for performing the replication, primary to secondary, what we required here, right? What are the pre-checks, what we required here to perform the primary and secondary replication? So regarding this one, we have the some preparation work we have to perform the configurations. So we have to do the some configurations. What are those?
Sir, one question.
Yes.
Sir, both are active, sir, or one is active, one is passive?
One is both are like that's if we are using the cluster, both are active only. Both are active only. So if you are not using cluster, if you want to put the this is the passive, then manually you need to fail over to the secondary. Manually you have to, because this is passive, manually you have to activate it. So both are active only. So both are active. Immediately something wrong here. Immediately there is a cluster service. Yeah, cluster services. Porosync and pacemaker are the Porosync and pacemaker. These are the Linux cluster packages we have to install in our system, so that whenever if any something goes wrong here, this pacemaker will check this one, will fail over to the secondary node automatically. So because this is active, immediately the system will automatically systems will connect to the this one pacemaker and Porosync ports. These packages we have to install, the Linux cluster packages, so that we have to do the configuration. So apart from that, so normally the replication to start to prepare the secondary, and so what we have to do. So first of all, both the first of all, both the systems, both the hosts should be reachable. Primary, this is the HANA 1, HA1 and HA2 should be reachable. Means if you just ping this one, it should work. If you ping from this to here, so in our case, if we use the ping SAP Linux 1, it should ping actually. So it should ping it. So it is not pinging from primary to secondary. Why? Because so in the etc file, in the host file, we have to maintain your Linux details also. We have to ping it as part of the preparation activity. So first we need to maintain our HANA, the secondary details also we have to maintain it here. This is our secondary HANA host here. Secondary HANA host. SAP HANA is the primary. SAP HANA 1 is our secondary host here. Right? We go here, etc host file. So we have the HANA 1. HANA is working. So if we go to the here, if you click in, that is working. You can see the ping is working. Means you are getting the response here. Right? But when you check from the HANA 1, it's not working. Why? Because I have not maintained this one. This is a very important here, right? So that's I have maintained here. Now just save it, WQ exclamatory. Now ping it. So now ping it. Now it is working. Previously it's unknown host name and everything. Now it's pinging. It's pinging from my HANA to HANA 1. Then HANA 1 to HANA, it is pinging. The response is getting. You are getting the response, which means both hosts are reachable. This is the first point we have to do. Both hosts are reachable status. Then after that, the second point. So then both SIDs, both are in the same space. Memory perspective, both are in the same space. Sub 39 GB, our Linux 1. So your first primary 36 GB. Fine. Why? Because this is, we will call it as the primary, only 3 GB difference. That is fine. We can negotiate. But because we don't have that much of data, that can be fine. Right? So that is fine. So memory also matching. What about the space, file system spaces? So slash hana data, everything is matching from here to here. You can also matching here. You can compare it. It's matching, right? To the enough space. Then what next? So we have to compare replication. Why? Because all the data which is coming from primary to secondary, then if you don't have that much of data, that much of memory, what will happen? So the replication, it won't work. Then you may face the issues, data loss issues when the failover happens, right? So that's the reason. So both should be in the same, both should be matching, and also free memory and everything. And also main important feature is like main important thing, very important feature. Same, you should install the same SID, same instance number, same SID, same instance number. You have to install it. That is the main thing here, which means you have to install the same SID, same instance number, same SID, same instance number. In the both the side, you have to do the this installation, right? Both the side, you have to do the this installation. And one more very important activity is, I will share the steps to you, no problem. One more thing is, in the primary, we have the in the data and key files. We have to place in the primary data and key files from here to, and secondary we have to place it. Then only secondary will go and register into the primary system. So the data and key files, then we will call it as the SSFS keys. So that we have to replace from primary to secondary. We need to move it. We need to place it here. Then only the secondary will talk to the primary. Then data replication will happens, right? So this one will do. Or you can perform this all these prerequisites for tomorrow. So what you have to do? So what you have to do? You have to perform all this pre-work. Tomorrow will confirm the replication. Why? Because in the hurry situation, if you configure, you won't understand now, right? So our primary Linux host, Linux 1. This is the SAP HANA. This is the Linux 2. This is the SAP Linux 1. This is our secondary host. Now you have to install the SAP. First of all, check the connectivity. You need to check the connectivity between the connectivity between the both the servers. Then, so what you need to do? Then install HANADB on both the servers, both the Linux machines. You want to bond with the same SID and same instance number you need to set. Then, so exchange the keys. So exchange the keys. Exchange, maybe that's not the good word. So copy the keys from primary to secondary, right? Then this one you have to do for this one. So this is your assignment for today. I will provide the steps how to do this one. You know how to installations, connectivity we have now. Now only thing is you need to copy the keys from primary to secondary, that you have to perform it. Then how to perform means, I will just nothing is there. I think in the primary you have the if I remember correctly, VSR SAP S4H, then sys global CD sys global / security. Here, yes, these are the files, data. So we go to the data. So data, nothing is there here. So I think leave something that will be generated here. Yes, these are the files. So this keys, this data and keys, these two, you need to copy same in the secondary box also, in the same location you have to copy it. So same way, this keys you have to copy from primary to the data. So maybe if I go to the key, you have to copy this two to, and here maybe you can use the WinSCP to move to the secondary. Then install it. Then keep it ready for the tomorrow's class. Then we can perform the configuration tomorrow. replication configuration. Okay, so nothing, just we can go for here, configure the system replication. System DB, configure the system replication. So then our primary HANA Studio, it's very simple in HANA Studio. So HANA Studio, it's very simple in HANA Studio. There also we can do the configuration. But before that, you need to perform the all this configuration. You have to perform it, right? Go to the here. So HANA cockpit is there, URLs are there, so everything is there. So you can just go to the here, then here. So what we can do? So here there is a replication option. Enable the replication option in somewhere, maybe database management, I guess. Yes, right. So here, so configure the tenant replication. So step 2, replicate the tenant. So what is the target database? So target host. So like that you need to choose it. So then you can replicate it. But that we will do tomorrow, not a problem, no hurries. So but what you do, you need to complete the pre-steps. So perform the pre-steps, install the HANA database into the HANA cockpit, add it, then we can perform the tomorrow configuration, right? I think today, differential backup is completed. Is it like our backup schedule?
Yes, sir.
Oh, so which means automatic backup scheduler is working now. Maybe we'll go and we'll verify. We should remove the previous one also, right? So we'll go for, yes, I think. So previous one is getting removed and the new one is getting created. This is the log backups. So means we have the 1 day retention period is there. So I think previous backups are getting removed and new backups are creating. So our backups are working, incremental backup, everything. Yeah, you can play with this system. Okay, you can play with this system. Let's see. Okay, so you can practice it. You can perform this all this